So we've done our tests. We've collected our dissolved oxygen. We've collected our bottles for dissolved oxygen. We've done our salinity test. We've done our pH and water temperature test. What I'm going to do now is this section on what's called a dissolved oxygen titration. And this is typically something that you can do at home. All the other tests are field tests. The air temperature, the water temperature, pH, salinity, that's all stuff that you'll do in the field. The dissolved oxygen typically takes some time to settle, and it's something that's easy enough to bring back home. Once you've added the first two chemicals in the field to your dissolved oxygen bottles, you'll get the cloudy sort of precipitate to it, which is a white precipitate. Once they've settled down below the label here, typically you would shake them up one more time so that it gets all the chemicals to distribute through the sample. And then once they're fixed with the first two chemicals, they're good to sit in this condition for up to 8 hours. So it's easy enough to bring it home and finish this second portion at home. So what I'm going to do is I'm going to talk about doing the titration. And we're going to do all three bottles for the titration. And when you do a titration, you are going to have some waste from your sample that you need to get rid of. Typically, if you live in a home where you have your own septic system, you're not going to want to dump any of this waste down your drain into your septic tank. Over a period of time, the chemicals can be harmful for the good bacteria that's in your septic system. So we don't want you to do that. If you live in a municipality where you're on your own wastewater, you're on a municipal wastewater system or town sewer, then small portions of these chemicals aren't harmful to put down the system, and you can use your regular kitchen sink. But what we're going to do is we're going to add another chemical to all three of these bottles, which is a sulfuric acid. And in your kit, it's labeled bottle number 3, and it has a red cap on it. We're going to add 8 drops of this to all 3 bottles, and it will change the color of this fluffy precipitate into more of a yellowish color to it. And I'm going to go ahead and do that quickly now. And again, you want to add it to all 3 bottles at the same time. You don't want to add the sulfuric acid to one bottle and then do your titration and then go back and do the other 2. You want to kind of do them all at the same time. We'll add 8 drops to each. And you notice that I'm keeping the bottle vertical. If I were to have my dropper on its side like this and add the drops, you tend to get a smaller droplet than you would if it was totally vertical, and we want to make sure that they're all the same. And we'll put that away. We'll put the caps back on. You notice it's already started to turn a little bit of a yellowish hue to it. So we'll take each of these and give them a good vigorous shake. You want to really kind of work your wrists when you do this because you want to make sure that it's well mixed. Sometimes you'll see what's known as like a pepper flake look to it. And often that means you just haven't shaken it up well enough and let the sulfuric acid work with all the chemicals. Sometimes there have been occasions where there have been contaminants that get into the sample that do mess up your end results. Typically you can see them in the water. Again, here's this white precipitate that's getting eaten up. So we'll give all 3 of those a really good shake. Now you notice that it does have a little bit of a yellowish color to it. The process that we've done, we've collected the water sample, we added the 2 chemicals to it to bind it up to this white sort of cloudy precipitate. Now by adding the sulfuric acid to it, what we've done is we've converted the oxygen that's in the water into iodine. And so we now can add some chemicals to these samples to actually measure how much iodine there is in the water. And there's a direct correlation of the amount of iodine to the amount of oxygen. It's basically been oxygen's converted into iodine. So that's why we have this sort of yellowish look to it. It's iodine that's in the water. We're going to need a couple of pieces of equipment. One, that is a titration tube. We're going to need some sodium thiosulfate. We're going to use a little bit of a starch indicator. And we're going to use this syringe. And this little syringe is called a titrator. And it's a scale from 0 to 10. And the titrator we're going to fill this titrator up with some sodium thiosulfate. And this is our measuring tool. This is how we'll be able to measure how much oxygen is in the water. The thiosulfate, when we add it to our sample, will eventually make the yellow sample slowly become a clear sample. At some point, it will be very difficult to tell whether it's clear or not. So we add some starch to the sample, which then will sort of turn it a purplish color. And then we can continue to add thiosulfate, and eventually at some point it will turn over to clear, and then we'll know what the measurement is. We'll read off of the syringe, and that will tell us how many milligrams per liter of oxygen there is in the sample. The first thing that we're going to do is we're going to take bottle number 1, and we're going to go in that order, bottle 1, bottle 2, bottle 3. We're going to take bottle number 1, and we need to pour 20 mils of this sample water in order to do our titration. This is about a 60 mil bottle, so we've got plenty of extra to use. We're going to pour off a little bit into here because, as we did with our bucket, our white bucket, when we collected the sample, we rinsed it 3 times. Well, we want to rinse this 3 times as well because it may have residue from a previous sample. So we're going to give that a little bit of a rinse. We're going to rinse that 3 times. And the bucket that you see below me, this gallon milk jug, this is something that we use for waste. And it has kitty litter in the bottom, which is something that will neutralize some of the chemicals, specifically the acids that are in here. And now we're going to measure out 20 mils. And what I want to do is I want to pour this off into this other tube. This is a titration tube. I want to make sure that this is rinsed as well. So I'm going to take a little bit of that, and we'll pour that into here. Put the cap on. We'll give that a little bit of a rinse. You want to make sure that the cap is rinsed as well. And then we'll get that rinse water as much as we can out of the jar. And we'll take our 20 mils that we've previously measured and we'll pour that into here. So that's the sample that we're going to process. One thing to keep an eye on, the glass jars that come with the kit, they have a little white line on here that says 20 mils. And if you look at it, the water level is not actually on the 20 mil line. It's a little bit above the 20 mil line that's written on here. The next thing that we're going to do is we're going to get our syringe or titrator ready, and we're going to use this sodium thiosulfate bottle, and we're going to take the syringe. In the top, there's a small plastic cap with a little hole in it, and we'll put that down into the bottle, and we're going to turn it upside down. And the first thing that you notice here is there's an air bubble that usually forms on the top of this syringe. Typically happens when you do it the first time because it's all dry, it hasn't been used, it's not wet inside. So we want to get rid of those air bubbles. Air bubbles can be a real problem. So if you take the syringe and give it a quick little jab or two or three to try and get rid of any kind of air bubbles that might be in there. And then you want to pull the syringe down as far as you dare to pull it down. Now I'm pulling it down way past the 0 mark on here, way past any of the markings, and I'll tell you about that in a minute. But pull it down as far as you dare to do it, and then pull the syringe out. We'll put the cap back on, put it back in. And so now the reason for filling it up beyond the markings on here is I have extra fluid. What I'm going to do is I'm going to add a little tip to the end of this syringe that is going to make the droplets a little bit more refined, and it's a little plastic thing. It's called a titrator tip. And what we're going to do now is use all that extra fluid that I put in here to fill the tip of the syringe. And we'll just kind of squish it up a little bit like that. If there are any air bubbles, then you can tap it like this a little bit. If you have your syringe pointed up, the air bubbles will want to climb up to the top. Give it a little bit of a tap, and then you can squeeze some more out. When you're confident that there's no air bubbles in the tip and there's no air bubbles on the little plunger on the bottom, what we're going to do now is we're going to set the syringe at 0. And we'll set it at 0 like that. Now we have a syringe that's at 0, and we know that every time we add some of the thiosulfate to our sample, we can actually measure how much, because the scale from 0 to 10 will tell us how much we've added. We're going to take this, and this can firmly get put into the top of your titrator tube. And we're going to start by doing a little drop, and we'll give it a bit of a swirl. We'll give it a drop and a little bit of a swirl. One of the common mistakes when you do this is to kind of swirl it around like this, and the syringe tends to be loose, and sometimes it can fly across the room. And some of these are glass, some of them are plastic. The glass ones tend to break, and then you're in trouble. So a good way to hold on to it is just kind of clench over the top of the syringe like that, and then you can do a drop at a time. This is a good way to hold it because you're actually holding the syringe from flying out, and you can see what you're doing. So what I'm going to do is I'm just going to keep adding a drop at a time, kind of swirl it up, just keep mixing it. And what I'm looking for is I'm looking for this sample to end up being a sort of pale straw color compared to what the original sample was when I started. So here's the original sample, and this is my new sample with some of the thiosulfate in it. It's a little bit more of a pale color to it. And I might go a little bit further to have a bit more of a pale straw color. But eventually, if I were to continue doing this, it would be so clear I wouldn't know when the end result is. So what we're going to do is we're going to add another chemical to it, which is called a starch indicator. And you can take the cap off. You can leave the syringe in the cap, kind of set it aside. And we'll take some of this starch indicator. And again, this is like all the other chemicals in the kit. It requires 8 drops. So we'll go. And it sort of starts to form a bit of a purplish color to it. Snap the cap back on, and we'll swirl it up. Now what I'm going to do is I'm going to continue to add more of this thiosulfate to the sample, and eventually we're going to get very close to clear, and then all of a sudden I'll add one drop and it will go clear. And we're getting close. And sometimes you can use your data sheet to kind of look to verify, is it clear yet? No, not quite. Getting close. Still has a little bit of a color to it. Poof. Looks like that one drop did it. So that's the end of the titration part. Now what we need to do is read the scale on the syringe. And the scale here, it looks like we're at 7.6 on the scale from 0 to 10. So 7.6 means that there's 7.6 milligrams per liter of oxygen in the sample of water. So on our data sheet, we would write down where it says dissolved oxygen in this lower portion, we would write down 7.6 for our first sample, which was the first bottle we just did. And we will get rid of this. We'll set this aside. Any thiosulfate that you have left over in your syringe, you can discard as well. We don't want to reintroduce that thiosulfate back into the bottle when we fill it up again for our next test. Our next test is bottle number 2. And we're going to do the same process with bottle number 2. And we're going to hope that the results for bottle number 2 are going to be in line with bottle number 1. Our requirements for doing the dissolved oxygen, again, we have 3 bottles. Most of the time, if you've done this testing before and you're a little bit proficient with it, you'll find that your first 2 dissolved oxygen bottles, your results will be very close to each other, within 0.2. Sometimes they'll be the same. I may have 7.6 again, I may not. But if you have results for your first 2 bottles within 0.6 milligrams of each other, then you're not required to do the third one. We encourage you to do the third one because the more you do it, the better you get at it. And there's a chance that your third bottle might be a little bit closer to one or the other. But if your first 2 results are beyond the 0.6 reading, then we require that you do the third one. If they're not, you don't have to do it. So I'm going to do the same as I did before. I rinsed it 3 times. We'll fill it up to the 20 mil line. We'll set that aside. I'm going to take my titration tube again, and I'm going to fill that with my sample. One of the things to keep in mind is when you read through this in the manual, in the instruction manual, there are step-by-step clear instructions of how to do it, and you can actually use that every time when you go to do your processing for your dissolved oxygen test, when you do your titrations. One thing to keep in mind is it says to rinse your titration tube. And a common mistake that I see people do is they'll actually rinse the tube with fresh water or with tap water from the sink, or they'll rinse the graduated cylinder with tap water before they go to do their testing. Don't do that, because what will happen is you'll introduce tap water or fresh water into the whole system, and it will give you readings that are all over the park. So you really don't want to do that. So we've rinsed that 3 times. We're now going to take our 20 mils from here that we've poured out, and we will put that in there. We'll put the cap back on. The next step, again, is to fill our syringe or titrator, and we're going to use the sodium thiosulfate. And we'll put that firmly into the top. Pull it down. Maybe about a 1/2 inch or so is good. Again, you're going to probably have a bubble in there, so we'll just kind of push that up and down a little bit, and then pull it down as far as you dare. Flip it upright. You might also want to just take a towel and wipe the tip off. Since this was used previously, it may have had some of the sample water from the previous sample get around the tip of it. So that we don't contaminate our other test, we'll just wipe that off a little. We'll snap that on there. Now we need to make sure that we don't have any air bubbles in the tip, and we'll kind of slowly push the fluid up. And when we're confident that there are no bubbles, we will set the syringe at 0. And now we're ready to process sample number 2. And we'll firmly put the syringe in the top, and we'll add a drop. Mix it. One of the things to remember when you're doing this titration is seawater can hold more oxygen in it when it's colder than it can when it's warmer. So when we're doing our testing, our season begins in April and ends in October. Those early months of April and May tend to be pretty cold water. So it's not uncommon that your results for your dissolved oxygen tests will be greater than 10. And the scale on the syringe here is 0 to 10. And you will find that you've put all the thiosulfate into this titration tube and it hasn't gone clear, and some people think, well, did I make a mistake? Did I screw something up? Well, you haven't. What it is it's telling you that there's more oxygen in there than 10. So in order to get the actual reading, you'll have to do 1 full syringe, and then you'll have to go back and fill it up again with the thiosulfate as you would a new test, and then continue doing your titration until it goes clear, and you would take the readings, the first 10 milligrams, and then whatever else you put in your second syringe worth. And it's, again, pretty common to see 12 milligrams, 11 milligrams per liter of oxygen in April and May, and again in October when it's cold. Summer months, an average for dissolved oxygen is going to be around 7 or 8, depending on the wind and a variety of other factors, plankton blooms and so on. At this stage, I'm feeling comfortable that this is sort of a pale straw color, again, compared to what I started with. It has a little bit more of a pale look to it. So I'm going to add some starch indicator. And we'll add 8 drops. And again, we're going to mix that really well. And eventually this is going to go clear. We're going to get really close. Again, I can check with a white background and look. It's not quite there. It might require a drop. what I'm going to do now is, when it gets really close, sometimes we can do what we call adding half a drop, which is by taking the syringe and kind of squeezing a little bit out onto the tip, but not squeezing it enough so that it falls in. And each droplet that drops into the sample is roughly about 0.2 milligrams per liter. And on the scale here, each little line represents 0.2. By doing a half drop, which is putting it to the end so that it dangles on the end and doesn't fall in, is typically about 1.1 milligram per liter. So you can get a little bit more refined. So have one dangle on the end and you can kind of splash it off, and that'll make it turn clear. I could have continued to push it through so that it was 0.2, but if I practice it enough, you can be a little bit more accurate with your measurements. And so we'll check the reading on here, and this one is 7.8. The first sample that we did was 7.6, this one's 7.8. It's certainly well within the 0.6 margin. 0.2 is kind of normal for people when they're doing the testing. They often have their first and second samples within 0.2. That's pretty average. One of the things to keep in mind when you do the testing, when you do your first sample and you get a reading, let's say you get 7.6 like I did, and then you do your second sample and you get, let's say, 7.9, and then you go ahead and do your third sample, and that ends up being 8.6. There's quite a spread there between results. They aren't very close to each other, and that tends to indicate to us that there's potentially something wrong with your chemicals. And one of the first culprits in that is to look at your starch indicator. And starch indicator is really just potato starch and water. There's nothing more to it. It's just starch that's been heated up enough to go into solution into the water. It's a clear liquid in the jar. But what will happen sometimes is if this tends to be in a cold environment, again, April, if you leave it in your car, for instance, for a couple of days, it might get cold enough for it to not necessarily freeze, but it will go out of suspension and it will become a cloudy liquid. The first thing that we would do is, if you called us and you had an issue where your readings were very far apart from each other, is we would have you look at your starch indicator and see, is it cloudy inside there? If it is, then we can either send you a new bottle of it, or you can do a quick remedy yourself, which would be to take the rubber stopper out of the bottle and heat the liquid up in here so that the potato starch inside does go back into solution. And that can be done either in a microwave. If you do it in a microwave, you're going to do it for no more than 10 seconds with the rubber stopper off. And then put the stopper back on when it's done and kind of shake it up. And continue doing that until it ends up being a clear liquid. And that will usually solve the problem. Sometimes there's some issues with the thiosulfate being old. This is typically a chemical that's only good for about a year, and it does degrade over time. Again, we ask you not to leave your kit and your chemicals in your car, especially when it's hot or cold, because extreme temperatures tend to degrade the chemicals. But those are the two chemicals that are more susceptible to having some issues with them. The rest of the chemicals in the kit are fairly stable, so you should be all set with that. And the third one, we won't need to do that because our first two readings were within 0.2, so we can get rid of that. On our data sheet, we will write down what our results were. We had 7.6 for the first one. We had 7.8 for the second one. On the data sheet, it also asks for our average. The average between these two would be 7.7, so we'll write that down. If you did collect if you did process 3 dissolved oxygen tests, we would ask you to average the 2 that are closest to each other and give us an average to it. Our database, when we put the data in, we're only allowed to put in 2 readings that are closest to each other. We can't put all 3 of them in. So, and that ends that segment. Thank you very much.